All right, guys, welcome back. Thanks for joining us for part 4. We're going to do it a little different this time, mainly because we've been talking about drawings and the different aspects of them, but I haven't really shown you how to make one yet. And we're going to kind of do all this, just incrementally. So if you're just watching this as a series, you'll kind of get to see, all the different things that you can do. To make a drawing from a part is normally what you would do. You could also draw it by hand or draw it and then bring it over to a part. All these are kind of interchangeable, and when you affect one, you affect the other. So if you have a part that's pulled into an assembly and you change that, or within the drawing, it's going to change all of them. So they're all interwoven. I forget the word that SolidWorks uses for that, but essentially think that when you start making parts that all come together within an assembly and then you create a drawing packet, they'll all be connected within the system. So with that, let's make a part, and then we'll make a drawing from that part. So you'll get to be able to do this the better you get. You'll be able to, your mind's eye will develop more, and you'll think about what you're going to do, and then you'll see it, and then you'll decide how to build it. Imagine almost like I don't know if you play video games, like you play Minecraft, and you originally are just dropped on in a world, a seed. You start to see things, and you start to build them. So it's try to take that same imaginative power, so to speak, and take it over to engineering. So, and what we're going to do here is, let's think about a pyramid, right? If a pyramid is built, it's most likely the bottom plane is on the floor. You're not going to make a pyramid upside down and have the point not sit where the gravity would want to pull it down to a side, so to speak. I hope that's making sense. So let's start on this top plane, and let's do a 4-sided pyramid, because that makes sense to me. And I made a mistake already. Let's back out a second. You might be able to call it my mistake if you're watching closely. I didn't change my dimensioning. I've done that before. So if you catch me doing that, it happens. Just don't make that mistake when you're making a big part, or if you're in a test, crunch time, you don't want to be making little mistakes like that. So, all right, we're in that measurement. And rule of thumb too, or a little tip there you could do. You could open 4 separate parts, right? You can make a little folder on your desktop that's called SolidWorks. You could start the part, select the measurement, and you could save each one of those parts and then label them in the name in the filing system what dimension is. That way you go and you open the part, you make it, then you just rename it. You already know you're in that dimension because you opened that part. You rename it to the part you're going to build, and then you go from there and you put the part where it is in your file system. So that's a little tip. I don't use that one because I like to think that I'm always going to open and go and check that, and I normally will always catch myself pretty quickly, because the moment I go to make something, I'll see that the measurement dimensions don't make sense. So not that bad, and it only costs a few seconds. So there's different ways to get around that. Think about playing smarter, not harder. Back to our triangle, our pyramid, so to speak. Center point rectangle. Let's go 100 by 100, because that's what we've been doing, right? Makes sense to me. We are now on the, if we look at it from the front, it looks flat because it's basically just the bottom slice of a pyramid, right? The bottom part would be a square, and as it goes up, the sides would taper inwards. Hold on, sorry. Okay, sorry about that. Had to get the phone. Back to what we were doing. We have our 100 by 100. We're going to extrude this, right? Because we need to take things up. And this is going to be almost like the box example, but if we did this 100, we're going to get that box, and we're going to get mid-plane. We got to go blind for a pyramid because we can't really extrude. We'd get more of a diamond shape if we did it the other way, and you'll see what I mean. We're going to draft this, and we're going to draft this at an angle. I think 30 degrees or maybe 60 degrees. 60 degrees is a really short pyramid. If we go 30, I think it'll be a little bit taller. Yeah, a lot taller. Let's go with 30 degrees because I like that look a little bit more. You could do whatever degree for your pyramid you want. But let's look at this. This line is our dimension blind of 100 millimeters. So if I move this around, it will eventually, I could like cut the pyramid off, and we could get, I think it's a trapezoidal or depending on the way you look at the side of it, shape. So you can do a lot of different things with this draft tool. It's a draft that drafts automatically inward, which is how you make this pyramid. And there's a lot of different reasons you'd make a small pyramid, like maybe you need a bunch of tiny pyramids on device for grip. And if you rounded off the tops of these little pyramids, and as it was manufactured, it would provide surface area, and they could be very tiny. So there's different ways or different reasons you'd make this kind of shape or this design, and you could do the measurements to see how long this length would be, and you could put the exact one in, and that's just some math. You will use math in SolidWorks, and there's, you could do it here if you wanted to, 100 minus 5, and it's going to give you 95. So know that you need to know your shapes. You need to know how to make these shapes, what angles and measurements and what does what. We could draft this outwards and make the opposite kind. But now if we, again, flipped it on its head, it's the same thing. But the difference being, when we look at it in ISO, how it would sit on the table, correct? So if we flipped it the right way, turned it off, flipped it the right way, now it's sitting on its table and the pyramid is going upwards, because that makes sense. So cool, that is a simple pyramid. We can end that, and because we use that center point rectangle and extruded off of the center, our center of mass is going to be a little weird. It's only going to be in the y direction because we're flat on the plane and it's center, and everything should be from that bottom. So if that all makes sense to you, I know these things kind of seem confusing or abstract as I talk about them with centers of mass within a 3D space, but you have to think about taking them to the real world and how it works, and imagine it physically in your hand. So some things to think about, cool ways to play with it. Now let's take this over to our drawing. So we're going to save this. Save as. We'll go back to our portfolios, basic shapes, part 4, mid, cool. And then let's go here. New, instead of a part this time, let's make a drawing. And you might get a drawing document. I have some from like ASU or the different places that have given them, that have their own models. This is just the basic ANSI landscape version that I use a lot because it's simple and it makes sense. So we can bring our pyramid in, and you can change the view you initially want to bring it in. Like if I want to start with ISO, I always start with front because that makes sense. Front. And then you just drag this around, and this now should make sense with what I was talking about earlier with, do I need this view? Is a question you can ask yourself. Do I need this view? No, because all the dimensions you're going to get from it can come from understanding what this view and this view does and what this view means. So let's finish that. Let's drag these around a little bit. These will always stay in line. These points will always be horizontal because that's how the views are programmed. The ISO you can fiddle around with. So that's how you would bring the parts into the drawing. Now to dimension it, you have your dimension tool, and I like to do things like this. Like you have your height, right? Oh, and you could tell I've made the same mistake here. You'd want these all in millimeters. And in drawings, it doesn't matter as much because as you click those buttons, things will jump around. It's easier to see. But just a quick thing to think about there. So we have the height. We can't get that from here, but we can get length and width of the bottom box from here. So let's do that on this image because that actually makes sense. It doesn't make sense to pull the length at that bottom image because it doesn't mean as much, right? Like pulling it here, it still makes sense, but it doesn't mean as much as seeing it here. So that's really all the dimensions you need, right? Well, not really, because how is someone going to know? You might be able to tell them to extrude to that height, but at what angle? So if you click these two lines, you get that. And you could do, I believe, times 2 here, times 3, because all of these should be by 60 degrees, right, if it's completed the angle. But that's kind of just over-dimensioning it, right? Yeah, they're all going to be 60 because it's an equilateral triangle. You could do that. You don't need to, because what do we know from triangles, right? Like, if you start having like 2 45s, you know what the other one's going to be because all of these add up to 180. And if you're looking at this the way it is and it looks perfect, you can almost make that assumption that all 3 of them are 60 degrees. You could go a step further and do this to make sure it's 100% clear. And then now the last one is assumed. So again, when you're making drawings, be thinking about stuff like that. You have to, how would you draw this? How would I make this? How would I build this? It has to be drawn how you would make it. And you don't want to go overboard, but you also want to give everything that the builder knows or needs to know. So cool, we have that now, and you could put some more information here or in the title block. Sometimes I do, sometimes I don't, if I'm making just a quick video for you guys. But this one's a little bit longer because we've covered some different things. And last note I'm gonna make, we could do a 3-point triangle. You could have done 3-point line within SolidWorks in the drawing, in the sketch, and done the same thing, but it would have come out simpler. All right, thanks guys.